Hello children, today we will be learning about something related to triangle. Here in the slide you can see different types of triangle. Here you can see equilateral triangle, isosceles triangle, scalene and right angle triangle. So today I am going to tell you something about right angle triangle. Here you can see a right angle triangle. It is special because each side is having a different name. Now you have the adjacent side which is also called as a base, and here the opposite side is called as a perpendicular, and the side opposite to 90 degree is called as the hypotenuse. So this is the speciality about right angle triangle. As you can see in the slide, Pythagoras Theorem. Pythagoras is a Greek philosopher of 6th century who is said to have found a very important and useful property of right angle triangle. Since he has given this property, it is called as Pythagoras Theorem or Pythagoras property. And here you can see that in a right angle triangle, the naming is done as A, B and C, where A is the base of the triangle, B represents the perpendicular of the triangle, and C represents the hypotenuse of the triangle. And Pythagoras theorem states that C square is equal to A square plus B square, where C is hypotenuse and it is also known as the longest side of a right angle triangle. So I'll be sharing the video where you can see the application of Pythagoras theorem in solving the problems. In Pythagoras theorem, it states that hypotenuse square is equal to the sum of base square plus perpendicular square. So now let us see two examples where it satisfies this theorem. So now I will take the first example, example 1, where the sides are 3, 4 and 5. So now I'll take this as example 1, and here I will take another example where 5, 4 and 6. Now these sides are the sides of a right angle triangle, and in a right angle triangle it states that hypotenuse square is equal to the base square plus perpendicular square. Now I'll just draw a rough diagram where I write down always in a right angle triangle the hypotenuse is the longest side. We know which is the longest side. Now if I take 3 cm, 4 cm and 5 cm, 5 is the longest side. So now I'll write the other two, you can write as it is. You can either interchange or you can write as it is. So now we will check whether this satisfies the Pythagoras theorem. So now Pythagoras theorem states that hypotenuse square. So now I will write 5 square is equal to, now 3 square plus 4 square. Already in 8th standard you people have learnt a chapter squares and square roots, where you have learnt the square numbers from 1 to 20. So you are aware of it. So now 5 square is 25, 3 square is 9 and 4 square is 16. So now you can see 25 is equal to 9 plus 16, that is also equal to 25. Here you can see left hand side is equal to right hand side, which shows that this satisfies the Pythagorean triplet. So now you have a new name which is called as a triplet. So now you have 3 numbers. So when you have 3 numbers and when they satisfy the Pythagoras theorem, we call it as a Pythagorean triplet. Therefore, you can write 3, 4 and 5 are Pythagorean triplets. Are Pythagorean triplets. Now let's see another example whether it is a Pythagorean triplet or not. The same way, now I will draw a rough diagram where, which is the longest side here? 6 is the longest side, and I'll write here 4 or 5. So this 4 and 5 you can either interchange and write. So that doesn't matter here. So now hypotenuse square will be equal to the sum of the other two square, that is base square plus perpendicular square. So now if I take 6 square is 36 and 5 square is 25. and 4 square is 16. So now 36 is equal to 25 plus 16. What is 25 plus 16? That is equal to 41. When you observe here, left hand side is not equal to right hand side. So now from here you can conclude that therefore 5, 4 and 6 are not Pythagorean triplet or not Pythagorean triplets. So from these two examples we come to know that whenever you have the hypotenuse square, it should be compulsorily equal to the sum of the base square and the perpendicular square. If not, then they are not Pythagorean triplet. So now we will see in the next video how we are going to find out one of its unknown value.